So, today I will discuss about one of the most important basic instrument in the optics laboratory. So, that is basically prism spectrometer and its leveling. So, in spectrometer, in optics laboratory, basically this prism spectrometer is used for many experiment. At least 30-40% experiment is based on this prism spectrometer. So, this before starting any experiment, there are some basic works has to be done with this spectrometer. So, that is basically we tell that is the leveling of the spectrometer. So, this and parallel also leveling for parallel rays. So, basically 3 steps. First step is mechanical leveling, then optical leveling, then parallel rays, leveling for parallel rays. Okay. So, this the picture is this spectrometer and its different parts are shown. So, the parts can be categorized like this. So, this what are the things are there? Basically leveling screws, then clamp screws, then fine adjustment screws, focus knob, height adjustment screws, then circular scale, vernier scale, adjustable slit for height and width for the source, then collimator fixed with base stands on. So, there is a collimator. So, collimator fixed with base. So, there is a base. Okay. So, that base stands on 3 leveling screw. Then prism tables with 3 leveling screw and height adjustment and its height is adjustable. So, collimator, then prism table and then basically telescope. So, these 3 main parts of this spectrometer. So, these 3 parts there are different screws I mentioned. So, they are basically they are used to label this collimator, the prism table and the telescope. Also their adjustment or this it's called this what I told this actually it's called clamp screw. Yes, as I showed for clamping the prism table, clamping the this telescope. Okay. So, these clamping screw are used. Okay. So, these things are basically whatever the screws I mentioned. So, they are attached with this collimator, prism table and telescope. So, prism table basically with 3 leveling screw and height adjustable, its height is adjustable and vernier scale is attached with the circular cover plate, which is basically prism table is attached, but not fixed, okay, with vernier plate. okay, cover plate, and then telescope fixed with circular scale. There is a circular scale that is fixed with the telescope, and also there is a cross wire for basically screen, where we will see the image. So, that we tell the screen. So, there is a cross wire at the screen place. Okay. So, here you see the picture. If we just zoom this part, this picture. So, here you can see these three main parts is that this collimator, this is collimator, this is collimator, and this is prism table, this is the prism table, and this is the telescope, right. So, this is the telescope, right. So, here you see the collimator. So, this is fixed with the this base. This is basically based on 3 leveling screw. This is one, this is another, and this is, I think, another one is here. You cannot see. Third one is here. Okay. So, this base is basically stands on these 3 leveling screw. This leveling screw means if you rotate this screw, then you can just decrease or increase this height from the ground. Okay. So, this collimator is fixed with this base, and this base stands on the 3 leveling screw. Okay. Now, in collimator what things are there? In collimator what things are there? Here it is at this end this adjustable slit, here it is called adjustable slit, and then there is a leveling screw, okay, and this another knob is here. So, this called focus knob. Okay. So, I think we should magnify this part, then it will be easier to show these leveling parts. So, focus knob, and so what are the things with the collimator? So, adjustable slit here, source basically put here, and then this light falls on this slit and pass through the slit. So, this slit basically act as a source for the experiment. Okay. Slit source, we tell slit source, and this and then this focus knob. What is the purpose of this knob, that I will discuss. And other end here basically there is a convex lens, collimator lens, we tell this is the collimator lens. Okay. And this leveling screw, it is actually here there is a knob, you can change the height to make it horizontal. Basically we can adjust the height, okay, of one end. So, other end is this end is stand basically this is stand on a platform. So, with this leveling screw, you can make it like this. So, to make it perfectly horizontal. So, that is the leveling screw. Then if you come to the next part, prism table. So, in prism table there are 3 leveling screw, this is one, this is another, and this is third one. So, using these 3 leveling screw, this platform of this table, the surface of the table is made horizontal, okay. And this is the height adjustment, this is the height adjustment screw for prism table. So, you can increase or decrease the height and you can fix it, okay. And this one, this prism table is attached with this cover, and vernier scale is attached with this cover, basically vernier scale is attached with this cover. So, this prism table you can, when you will rotate this cover, this prism table also will rotate, that means this vernier scale will rotate with the prism table, as well as also without. So, if you just rotate this prism table without rotating this vernier scale, you can rotate this prism table, okay. And then this part is basically telescope, this is the telescope. So, at this end again like collimator, here also there is a lens, okay, convex lens, and other end basically there is a eyepiece, okay. So, in telescope we have a lens at this end, convex lens, and at other end there is a eyepiece. So, and it has also leveling screw like collimator, you can adjust the basically this type of tilting to make it horizontal, as well as there is a focus knob, okay. So, this focus knob, whatever I am telling, both are present at the collimator and present at the telescope. So, this focus knob is used for focusing, means, so there is the lenses are there, and this slit source is basically this knob, focus knob, when you are rotating this slit, it's a move in and out, okay. So, this slit basically attached with a tube, that tube is inserted into the collimator tube. So, with this focusing knob you can change the position of the slit, okay. So, focusing means we want to put this slit, this source, at the focal point of this collimator lens, okay, convex lens, so that when a source is at a focal point of a convex lens, then you will get other side, you will get parallel rays, okay. So, if you, so that is the basically we tell focusing, and this for other focusing for the telescope is basically this eyepiece, here basically again focusing knob is there. So, this focusing knob we are rotating means this there is a tube, where this crosswire is put, means that crosswire plane is taken as a screen position, okay. Image will form on the screen. So, instead of screen we put the crosswire. So, this crosswire plane basically act as a screen. So, and the eyepiece is nothing but another lens, convex lens. So, that eyepiece basically that lens fixed with a tube, and that tube is put into the tube of the crosswire, okay, and that tube of the crosswire is again put in the tube of the eyepiece, okay. So, eyepiece basically is put basically in such a way that the crosswire will be at the focal point of the lens of the eyepiece, okay. So, now will not disturb the position of the eyepiece into the cross-wire tube. Now, and this eyepiece is basically it is fixed in the cross-wire tube. Now, this focus knob you are rotating means this cross-wire tube is going in and out, you can take in and out. So, we want to put that cross-wire plane at the focal point of this telescope lens. Okay. So, that is the that is called focusing, means here parallel rays are coming from the collimator. Now, prism table here either will put prism or the grating. Okay. So, now other side refracted or diffracted rays will come, as different sets of parallel rays will come. Now, that parallel rays if you want to see the image, so that we have to focus on the focal plane of a lens. Okay. Then this image will form at that focal point. Okay. So, basically this focus knob we are rotating to place the cross-wire plane at the focal point of this lens. Okay. So, that is basically focusing, and this is the circular scale just below this cover plate, okay, with which these vernier scales are attached. Below that one there is a circular scale, and that circular scale is attached with the telescope. So, telescope, sorry, this is the telescope. Okay. So, if you rotate the telescope, that means this circular scale is rotating. So, here this collimator is fixed, you cannot rotate, you cannot change the position. Okay. Prism table you can rotate. So, vernier scale will rotate and the telescope you can rotate. So, this both table will rotate with respect to a common axis. So, that axis pass through the center of the table. Okay. So, this is the axis of rotation for the prism table as well as the telescope. Okay. So, now your reading will change due to the rotation of either prism table, means this vernier, or the telescope, means the circular scale, rotation of the circular scale. Okay. So, to take this reading one has to use the magnifying glass. So, that here generally whatever cover on cover this vernier are there. So, they are generally two magnifying glass so is attached. Sometimes it attached or sometimes it is just common transparent plate is fixed. Okay. In that case you have to use magnifying glass, and there are screw, these two screws are there, is called clamp screw. So, prism table you can rotate as well as this telescope you can rotate. So, after rotating, if you want to fix at a particular position, so you can clamp it. Okay. You can clamp prism table as well as you can clamp telescope. So, these two clamping screws are there. So, these two clamping screw, as well as there are fine adjustment screws. Okay. So, after clamping, so if you want to change minor rotation of prism table or the telescope, so there is a knob for fine adjustment. So, this is one and this is one, and other should be I think this one. Okay. So, this for this is for telescope rotation. Okay. fine adjustment screw for telescope and clamp screw for the telescope, and this is clamp screw for prism table rotation and fine adjustment screw for the prism table. Okay. So, so there are many components, okay, small components attached with the prism spectrometer. So, you have to know what is the function of this each component and how to use them, okay, for our purpose. So, I will proceed more. So, if I basically what is the purpose of labeling of the spectrometer? Okay. So, common sense tells that for optical experiment you need light source. There is a light source, light will come and then it will fall on a optical device. Okay. It will fall on a optical device, then there will be reflection, refraction, diffraction, whatever something will happen, and then they will move, okay, and they will form image. So, you need basically screen. So, source, then optical device and then screen. So, in spectrometer basically they are equivalent, okay. Equivalent components is basically collimator, prism table and telescope. Okay. So, here you can see if this light source, say this is on this plane, there is a hole here on this plane, there is a hole. So, light is coming through the hole. So, this hole acting as a source. Now, if light is coming, so small hole is there, so light is coming through it. Now, if this screen is not say vertical this way, if it is rotated, then what will happen? Light will go along this direction. Okay. So, it will not go in this direction. Similarly, if this lens, it is say on this plane, it's a say holder, okay, it's a holding this lens. Now, if this holder is not this way, it's not say this vertical. So, if it is rotated like this, so what will happen? So, light will go. So, light will go this way and image will form here. Okay. Instead of forming image on the screen here, placing here, so image will form other place. Okay. So, and the screen also, if it is not this way, so if it is rotate, then you will not get circular image when the source is circular. Okay. So, if it is rotate, so this image will be deformed. Okay. So, it will be elliptical. Okay. So, this is very important to keep them vertical, Okay. So, that means this collimator should be kept collimator axis, basically this vertical I am telling this it's basically axis of rotation, axis of rotation. Okay, here here axis of rotation is this one. So, this can be tilted like this. So, because this is the perpendicular plane. Okay. So, it is rotated this way, okay, or it can be tilted like this. So, we have to make it this way vertical with this, the direction of light should be this plane should be vertical with the direction of light. Okay. So, in case of collimator, so this collimator, this tube is like this. So, this is the slit source. Okay. So, now light, so this vertical axis, it should be vertical, and this plane should be this surface axis of the tube has to be horizontal, and this perpendicular to the tube, it has to be vertical. Okay, that is the condition. If it is not vertical, so it will up and down. Okay. So, now you imagine light will go in either in this plane or this below to this plane. Okay. And if it is not horizontal, again light will go this way or light will go other way. Okay. So, similarly prism table also has to be horizontal. That means, this normal to the prism table has to be vertical and surface of the table has to be horizontal. Okay. Then only when any optical device like prism or grating you will put here, so that will remain vertical as well as its surface will be horizontal with the prism table. Okay. So, similarly telescope also, this telescope tube has to be so its normal has to be vertical and its axis length has to be horizontal. So, collimator, prism table and telescope, okay, it has to be horizontal, and normal to the collimator, prism table and telescope surface has to be vertical. Okay. So, that is basically that is necessary. That I try to tell you showing this example, that if it is not, then what will happen? We want basically light will go this, that should be this should be horizontal, this should be horizontal. Okay. This line has to be horizontal. Okay. It is not light should not go this way or this way. Okay. So, that is basically we have to achieve it. For that we need labeling of telescope, prism table as well as collimator. Okay. So, that is the purpose of the labeling. So, how to get it, how to do this labeling? Basically you can operations for labeling the spectrometer. So, there are few steps, okay, for labeling the spectrometer. First step is the basically mechanical labeling. So, in mechanical labeling, these are the things that we have to use. These 3 base labeling screw we will use, then 3 prism table labeling screws we will use, 2 collimator labeling screws. So, basically there are 2 collimator labeling and 2 telescope labeling screws are there. Okay. Below the, so in picture whatever I showed, this one was seen, another one was not seen in the picture. So, so basically these screws, labeling screws will be used for the mechanical labeling. So, purpose is to, as I mentioned, purpose is to make the telescope, prism table and collimator perfectly horizontal, and normal to them has to be perfectly vertical. Okay. So, so first from eye estimation, this basically this you can just make leveling the base and then collimator and then the prism table, okay. Collimator, then telescope and then prism table. So, you should try to make roughly horizontal. Okay. So, that is for my estimation. You rotate the screw, basically adjust the screw, okay, in such a way that you make them horizontal from your eye estimation. Okay. So, then put the telescope in line with the collimator. Collimator is fixed, okay. Telescope we can rotate. So, you have to if it is locked, so you have to unlock. So, clamping screw are there, unlock it, you rotate it and take in line with the collimator and place the spirit level on the telescope tube along its length, then use telescope leveling screw to bring the air bubble towards the center of the spirit level. Okay. So, this is the after eye estimation adjusting the leveling screw. So, you use the spirit level, put along the length of the telescope. On telescope you put it along the length of the telescope and then use telescope screw. Two screws are there. You use them. You rotate the you rotate the leveling screw, telescope leveling screw to bring the air bubble towards the center of the spirit level. Okay. Now, you rotate the telescope approximately 180 degree, just this close to the telescope collimator, okay. And again repeat the, again you see this whether this spirit level, that air bubble is at the center or it has change. So, again you adjust the in that case you adjust the base leveling screw, leaving the base leveling screw below the collimator. So, there are 3 leveling screw in the collimator, sorry, in the base. So, one leveling screw below the collimator, generally sometimes this is the fixed one or sometimes you can adjust the height. So, leaving that one, the other 2 screw, okay, leveling base leveling screw. So, that you rotate to bring the air bubble at the center. Okay. So, keeping this telescope at 180 degree, that means is close to the collimator. Okay. So, then next you place the spirit level on the collimator along its length, like telescope, the way you put on telescope, the same way you put, and bring the air bubble at the center, turning the collimator leveling screw. Okay. So, using the spirit level, so this way basically bringing the air bubble at the center of the spirit level. So, first telescope we are making horizontal using the telescope leveling screw, then telescope putting at 180 degree, we are using the base 2 base leveling screw, leaving the third base leveling screw below the collimator. Okay. So, repeat the operation few times for this. So, then this your telescope is mechanically horizontal. Okay. Then we make the collimator horizontal using this spirit level and turning the collimator leveling screw, and then you will place the spirit level at the center of the prism table, and in prism table there are 3 leveling screw. Okay. So, so spirit level you put in such a way that it will be parallel to the line joining 2 leveling screws. Okay. Now, to bring the air bubble at the center of the spirit level, so turn these two screw, this which are parallel to the spirit level. In this screw you rotate in opposite direction. Okay. So, opposite direction means if one is clockwise, so other one will be anti-clockwise. So, is height of this one side is increasing. So, height of the other side will decrease. Okay. So, because for leveling it's since it is put in parallel to these 2 screw. So, to bring the air bubble at the center, so it is necessary, if it will be necessary to increase the height of one corner, means we using a one screw. So, definitely this other side it has to be opposite. Okay. So, that is why we tell rotate them in opposite direction. Okay. So, now then place the spirit level perpendicular to that line, joining to that which line that joining the 2 leveling screw. Okay. And putting in perpendicular to that joining 2 leveling screw, you turn the third screw to bring the air bubble at the center. Okay. So, and then you repeat this operation few times, so that this spirit level, this air bubble in the spirit level, it will remain at the center. Okay. So, that is then your mechanical leveling for the telescope, and then collimator, and then prism table. All these 3 main components is done. Okay. So, I will stop here. In next class I will continue the other adjustment. Thank you for your attention.